I need to define another word at you. Okay? So, a function, let me say f of t for kicks. Because I really do want you to think about this kind of in terms of time. So I'm going to put t as the input variable here. So a function f of t is increasing. You guys know what it means for a function to be increasing? Yeah, perfect. So it's increasing if a less than b means f of a is less than f of b. You guys with that?
Yeah.
So please note that flat functions are apparently increasing.
Flat function?
Yeah, like this is a flat function, right?
Yeah.
And under my definition, I've said that's increasing.
Yeah.
It's a little bit wonky, right?
Yeah.
So I would like you to add to your brain the word strictly, right? And if something's strictly increasing, then these can be hard inequalities. So if I say strictly increasing, it's definitely going up. And if I say increasing, it's either flat or going up. Guys cool with that?
Yeah.
Okay. So I want to give you some alternate characterizations. So another option, another way to think about this would be to say the rate of change is,
It's positive.
yeah, it's positive, right? You guys see that? Right, because a change in f per change in time is going to have the same sign. Please note it's possible for that thing to actually be 0.
Wait, what'd you say?
It's possible for that thing to actually be 0. Right? Over here, the rate of change is 0. You see that? So if I wanted strictly, I would put like actually bigger than 0. You guys cool with that? Okay. Further characterization. If you squint at it, what does it look like? If the rate of change is positive, and you just kind of squint at some squiggle, right?
It's going to go up.
Yeah, it's going to generally go up, right? It's going to look like a line with a positive slope, right? The rate of change is positive, right? It's going up as you go from left to right.
Yeah.
Because as you get bigger in time, you go up in graph.
Okay.
You guys cool with that?
Yes.
So basically, if you kind of step far enough back, it's going to look generally rising. You guys cool with that?
Yeah.
Like, it doesn't have to be a straight line, right? It could be squiggly. But this is increasing, and kind of in general, it's positive.
Yeah.
Like, you're thinking positive slope at it. If we went through this whole same thing with decreasing, right? Which it looks like you guys are a little sleepy for. If I did further along in time, I would get a decrease, right? So I would get f of a is bigger than or equal to f of b. And the important thing here is that that would look like a line, what?
Going negative slope.
With negative slope. You guys cool with that?
Yeah, strictly.
I'm assuming you can fill in the appropriate translation of all the stuff from the top definition to the bottom one. What was I saying about the rate of change? That one should be
It's greater than less than 0.
is less than 0, right? And the same strictly stuff applies. You guys cool with this?
Strictly strict. So a flat line, a horizontal line is both increasing and decreasing.
A horizontal line is both increasing and decreasing, but is neither strictly increasing nor strictly decreasing. You guys see that?
Math amateur.
So, point of fact, I would never call a horizontal line increasing or decreasing if I had to say it. I would say that is constant.
Yes.
You guys see that?
Uh-huh.
If the rate of change is 0, we say it's constant. Cool? So that gives you 3 new words: increasing, decreasing, and constant.
Yeah.
Cool? All right, and because you guys look sleepy, I'm going to let you go.
Well, thank you for teaching.